Now maybe we're at a phase where the practitioners can come in and say, I'm not an expert in machine learning, but I do have a problem I want to solve. I know how to address that problem, and can the tools that are available today help me get there? And what I want to do now is show you some of my favorite examples of people who have done exactly that. So we start off with a group of astrophysicists at Stanford who had the problem of solving gravitational lensing equations. So what does that mean? It means there's a galaxy far away, its light is coming towards Earth, and in between there's another galaxy that bends the light. And if we could figure out exactly what's going on, we could essentially weigh that galaxy and figure out some interesting stuff about dark matter and so on. And the way physicists have been solving that problem is saying, we have physics equations that go in the forward direction. If I knew exactly what these galaxies were like, then I could predict what the light is like. So I'm going to run that on my supercomputer and compare that to the light I actually see on the telescope. And if it's wrong, then I twiddle it a little bit and try again. A long, error-prone process. These astrophysicists says, I'm a physicist, I know how to do that. I don't know anything about this machine learning stuff. But from what I read in the newspapers and so on, I understand that they can differentiate and they can go backwards rather than forwards to say, from the light, can I go back to what the model is? Maybe that would help. And in a couple of months, they were able to make that work and result in something that runs 10 million times faster. Now, that was a great advance that they very quickly learned everything they needed to do and solved it all by themselves. Of course, these are physicists we're talking about, so these are people, when you say the word tensor, as in TensorFlow, they don't get nervous. They say, I eat tensors for breakfast. Another similar example here. So this is the Kepler telescope, which is trying to find exoplanets, trying to find planets around other stars. I was at NASA in 2000, and I worked on sort of a precursor mission called SOFIA. And the idea is that a planet orbits this other star and forms an eclipse, and so the light from the star is decreased, and we should be able to recognize that. And back in 2000, when we were thinking about that, we said we're going to use sort of standard statistical techniques, and we think those techniques are good enough that if it's a really big planet that's really close to the sun, that's going to block enough light, we're going to be able to detect it. And that's exactly what happened. And the first couple hundred exoplanets were discovered by those techniques. Once we've mined all that data, now we say we want to do more. We want to say, are there smaller planets that are hidden out there? And now the statistical models just weren't precise enough. We needed a model that would pick up all the vagaries of what else is going on. Is the light of the star varying? Is there an asteroid field in between or so on? And so we applied deep learning to that, and we were able to go back and find new planets that were undiscovered before.